structure API, DataFrames and Datasets, and standard library like machine learning, graphics, and streaming, and how we are going to run the Spark application, and then go to details and machine learning's models. In machine learning, it's a high level, and so let's talk about this one, right? So our review, we have data source, and I think if you guys able to see or not, maybe my diagram. So high level data source, we can use batch data for Spark context, for streaming, Spark streaming, and transform and action, real-time processing, then Spark core is convert, and then optimize execution, catalogs optimizer, and for memory we use function engine. For final execution we process output layers, can be data warehouse, data boards, BI tool, storage, and so on. So Apache Spark, if you know or not, but in my previous lecture, if you can go here, so there is my previous lecture and coming about Spark. You guys can go through that one. But in this, I cover most of things about architecture in the previous lecture. So I'm not going to the architecture. So now I'm going to talk about the core component of Spark, right? So today I'm going to talk. So first core component is Spark API and library. So when we talking about Spark API and library, we divided into three parts: low level API, and which we call RDD, and then structure means it has a proper structure, and it is two types: data frame and data sets. Data frame is basically a schema based API, and data sets is the type shape API. And then we have standard library like SQL library for Spark SQL, real time for Spark streaming, machine learning for mlibs, graphs analytics for graphics, right? Okay. And so this is how which we talk. So Apache Spark offer of comprehensive set of API built-in library that is enabled for diverse data processing capability, including both batch and real-time data processing, graph analytics, and machine learning as well as. So ecosystem divided into three layers, which I already talked, right? And low-level APIs, structure APIs, and standard APIs. And then how we are going to run, right? So Spark in production application with the Spark Summit. So we basically use this command, Spark Summit, and then we need to use master yarn for deployment mode. Master equal to yarn. Deploy mode is cluster mode. Number of executor is 4. Number of executor memory is 8. Class, we are passing some app. This class is app. So basically this is what. So define cluster. Here is master cluster, maybe local, yarn, Kubernetes, and cluster manager. Setup deploy. Deploy mode is like client mode or cluster mode. Okay. So single node, multi-node. Configuration number of executor, we need to pass parallel processing for number of executor use. Okay. Allocate memory for memory allocation, pre-execution memory. Specify main class code, and execute Spark job, Spark cluster job execution, and it will go to distribution mode and then process data and the store data. So Spark submit and command line use the deploy Spark application on cluster. Okay, and it allow to configure resource, set environment variable, and execute Spark. So this is the parameter which we are passing. So master define the where run the Spark. Master means basically where is Spark run the code, right? Local, yarn, Kubernetes, etc. Deploy mode is client run driver. I mean deployment mode it is cluster modes, or driver runs on the clusters or something like that. Okay, number of executor parallel processing, executor memory allocated per executor. This is per executor class. So running Spark job production environment with proper resource management. It's very, very important. Now we are going to talk about third one is datasets or type shape API. So I said datasets and RDD and data frames, right? Switch. So it's convertible. This to this we can convert. This to this can convert. So datasets is a strong type, and data frames. So 2DF data frame, 2DS datasets, 2 RDD. So this is why the methods. Datasets are type safe. So dataset type safe version of data frames. Primary use for Scala and Java. They allow user to define a schema at compile time, reducing runtime error. That's very important. Compile time, so it will reduce the error. And here, if you see, I define a class. Person name is string and age is name is string, age is integer. So here read option header CSV as a person. So here is it will become data sets, right? Because it has strong typecasting and yeah, and strong schema defined. So compile time, avoid runtime schema mismatch. So this one we define compile time. Okay, optimal execution using Spark catalog optimizer can be convert between data frames and RDD. So this can be convert. Use case best structured data processing where the strong type is required. So when we require a strong type, we can use. Streaming means on the live data or real-time data. So streaming data like Kafka file stocks, read stream, and this is micro continuous processing or micro batching scalability. Transformation check finding, fault tolerance we achieve like checkpointing and write ahead logs. Write stream, console output, database can write, dashboard can write. This is example. We are reading from Kafka and we are selecting some string value and converting. Fault tolerance support checkpointing and wall. Support multiple source, Kafka file, socket, etc. Stable and use micro mini batch. Use case processing real-time data stream for fraud detection IoT data. Now we are going to talk about machine learning. So machine learning Spark also support. This also supports various kind of ML algorithm, classification, regression, clustering, uh, and feature engineering, right? Classification means 0 and 1. So logistic regression and decision tree, regression uh, Maxler, reg params, elastic param, pit models of the zone clustering, k-means, and Gaussian mixture. Recommendation use collaborative filtering, feature engineering, vectorization, normalization. This is what classification and regression, logistic regression, a decision tree, clustering use k-means, Gaussian mixture methods. Recommendation use collective filtering, feature engineering, vectorization, normalization. I'm not going to details. I have also the created machine learning course I'm giving to you guys in my Medium page. This is one program how they use. So classification, logistic regression, and reading this file, and then we are doing logistic regression. Max iteration is 10, reg parameter 0.0, elastic parameter is 2, so on. Use training and deploy scalable machine learning model on the large data sets. Now RDD is a low level distributed collection of provide fine grained control over computation. RDD, this is the example. So RDD also fault tolerance, distributed in memory, operation transfer map filter, so on, right? SparkR, SparkR allow data scientists and statisticians use Spark with R language. An example, if R is a little bit different, I'm not going in details. And this is very important, third-party package ecosystem. So Delta Lake is very important now, very popular ACID computation in the Delta Lake. Koalas is pandas like API, graph frameworks, and hyper opt distributed hyper opt tuning. So this is what I'm going through, guys. So please watch, like, share, and you can go through this diagram, and this is very important. Yeah, so this is what we cover, and if you feel it's big, cannot see, but you zoom it out and see it. Thank you.